Okay, so see, while designing a component, it is necessary to provide sufficient reserve strength in case of an accident. Okay, so this is achieved by taking suitable factor of safety. Now, what is the meaning to take the value of some particular amount of factor of safety in design procedure? Let's say, in order to design any particular machine element, designer should calculate all the types of forces, okay, acted on that component, and along with that, all the types of stress, okay, present inside that component. Okay, so designer required to calculate how much amount of stress produced in that element during operating condition. So say this is one part. Now you have to select particular material for that design component. That material have some ultimate tensile strength, yield strength. So these specifications are present along with that material. So when that component perform good or perform safe operation, when whatever the produce stresses on that design component, okay, that value must be less than the strength of the material, then and then only you can say that material that component perform well during actual working condition. So two particular points that you have to understand. First is what? Amount of stress generated in that component during working condition and amount of stress regarding the material that you select. Okay. Now at every time, it is not possible by designer to predict all the forces present or acted on that component. Somewhat forces, because of very complicated uh, shape of that component, may be neglected by the designer, or during manufacturing inaccuracy and all that thing, somewhat of the forces neglected by the designer. Then what happened? Whatever the stress calculated by designer, that is not actual stress during actual working condition. Somewhat more stress is present over there during actual working condition. But that stress we don't know. Okay. So if we are considering whatever the stress calculated by designer, that is the maximum stress, then in actual working condition, what that component will get fail. Okay, so what we require to do in this case, we have to increase somewhat amount of stress. Okay, let's say designer stress whatever the forces acting on that component, and accordingly designer come to know that 80 newton per mm square, that much amount of maximum stress present during actual working condition. But because of complicated shape and some hidden forces, in actual practice it may go up to 85 newton per mm square. And if you are design it according to 80 newton per mm square, then in actual practice it will get fail. So what we do, we have to increase that stress amount by multiplying somewhat amount of factor. Okay, and that factor is called as what? Factor of safety. So let's say 80 newton per mm square, that much amount of stress is acted on that component. And if you take factor of safety is 2, okay, so 80 multiplied by 2, it become what? 160. So you are considering 160 amount of maximum stress. Okay, at that 160 amount, the particular component will not get fail. Okay, so that is that multiplying factor is called as factor of safety. And how you calculate the factor of safety? Material strength upon the working strength, okay, or allowable stress over there. So this is the general formula: factor of safety, material strength upon working stress or allowable stress. Now the allowable stress is the stress value which is used in the design to determine the dimensions of the component. Okay, so allowable stress, okay, from that designer will able to obtain the dimensions of the component. Okay, now let's see this, how we calculate factor of safety for ductile material: yield strength divided by working stress or allowable stress. Likewise for brittle material, which particular strength we consider? Ultimate tensile strength. Okay, so ultimate tensile strength divided by allowable stress or working stress, that is called as what? Factor of safety. So there may be a short note that may be asked in your examination, or in a MCQ, there may be a question like how we determine factor of safety for brittle material. and four options are there, like yield strength upon working stress, or ultimate tensile strength upon working stress, and some two other options may be there. See how to choose a correct one out of that. So it's about what factor of safety. For fatigue loading, yes, this is another type of loading. Fatigue loading means what? Whenever the forces okay present on that component vary with respect to time, then you can call it a fatigue type of loading. And into that, endurance limit is required to take as a design stress. Okay, so endurance limit divided by working stress or allowable stress. So these are the different ways to calculate factor of safety, or you have to consider the factor of safety. Now, on which factor, the magnitude of the factor of safety is depend upon, first of all, let us say type of load. Okay, the factor of safety is totally consideration. The factor of safety value is totally considered by designer. Okay, so the factor of safety is low when the external force, let's say, acting on the machine element is static one. Okay, and you have to consider more factor of safety when impact load is there on the machine component. Okay, so you have to first see which type of load is present during actual working condition. Let's say it's a static one or impact one. If it is impact load, okay, you have to consider more factor of safety. So type of load affect the value of factor of safety. Then degree of accuracy in force analysis. So this is again very important. When the forces acting on machine component, okay, are precisely determined. I already told you about that. No any you can say ignorance about a very small amount of forces and all that thing. Precisely you have to determine the all forces. If designer complete that work very carefully, then you have to consider low factor of safety. On contrary to that, you have to select higher factor of safety when the machine component is subjected to a force, we can say, whose magnitude or directions are unpredictable or uncertain during actual working condition. Okay, so what is about degree of accuracy in force analysis? When designer precisely calculated all the forces, okay, then you have to consider low factor of safety. When the force direction is unpredictable during actual working condition, then you have to consider more factor of safety. Material of component. Now, how it affect? When the component is made of homogeneous material, okay, homogeneous ductile material, say like steel, okay, then when the material is homogeneous, okay, you have to consider low factor of safety. And when material is non-homogeneous, like cast iron, okay, you have to consider more factor of safety. Okay, so you must know very good knowledge about the structure of the material also. Then the cost of the component. Yes, now it is very important thing. How the cost of the component affect the factor of safety? If you select higher value of factor of safety, the size of product will get increased. And as the size of product will get increased, more amount of materials is required. As more amount of material is required, its cost is also get increased. Okay, so ultimately, what is our conclusion about that? When you will select more amount of factor of safety, its cost is also increased. Along with that, its safety is also get increased. Okay, so you have to optimize that thing. Quality of manufacture. When the quality of manufacture is high, okay, variation in dimension of machine component are less. Okay, so you may select low factor of safety. And conversely, higher factor of safety is required for poor manufacturing quality. Okay, so you have to also focus on manufacturing department where it is produce low variation product, or it may have poor quality of manufacturing over there. Service condition. If the component is working under corrosive environment, okay, then you have to consider more factor of safety. Then effect of failure. Now, effect of failure is very much important. Let's say, what is the effect after failure of mechanical component? Let's say bearing failure in gearbox. What is the effect? The gearbox stop its working. You have to open the gearbox and replace that bearing. This is the only work that you require, and bearing cost and all that opening prices are required for you. But what about the failure of safety valve in pressure vessel? Okay, in industry, it may create a blast of that pressure vessel. It may create there may be very hazardous condition, or it may affect the life of worker over there. Okay, so what is the effect of failure of that component, pressure vessel? Okay, so for that purpose, pressure vessel and all that safety wall of the pressure vessel, all that component must have very high amount of, or you can say considerable amount of factor of safety you have to consider as compared to the bearing failure in gearbox, like that thing. So this is about the 7 points you have to be focused while selecting the factor of safety.